Hello. In this video, we're going to review some homework problems for inductors. All right, the first thing that we're going to do is review some formulas and some of the keys to solving these problems. The first thing to note is when we're looking at symbols, this is a resistor. When we have inductors, we're going to use this symbol. So it's inductors are L in our formulas. If we have inductors in series, they add like resistors in series. So here I'm showing L1, L2, and L3. And the total inductance, L total, so if we're looking at a circuit here where we have an AC supply, we're not going to worry about series and parallel inductors in DC. So this is an AC supply. The total inductance is going to equal L1 plus L2 plus L3. Now if we remember, once we have a frequency, once the frequency is known, we can figure out the inductive reactance. So X sub L is inductive reactance, and this is similar to resistance. So when we solve the problems, X sub L is going to be what we're going to use to find the current. So this is like resistance. The formula for X sub L is 2 pi times the frequency times the inductance. So on here in this formula, pi is 3.14, so we can just use that as a number. F is the frequency, which should be given for the problem. If one of the frequencies is known, so let's say that this is 60 hertz, that means the frequency in the whole problem will be 60 hertz. And then L is the inductance. So we can find the inductance of a single inductor. If we know what the inductance of that inductor is, we can find the total inductance. If we know the total inductance, we can find the total inductive reactance. So our next formula here is that we would have for each one of these inductors an X sub L. So this would be XL1, XL2, and this would be XL3. So we'd have an inductive reactance for each of the resistors, and X sub L total would equal X sub L1 plus X sub L2 plus X sub L3. Also, X sub L total would equal 2 pi times the frequency times L total. So if we knew the L total here, we could find X sub L total there. All right, and then for this problem, once we know the total reactance, the total voltage, so that would be the total voltage here, is going to equal the current total times X sub L total. So we'll notice here that in our Ohm's law formulas, X sub L is replacing R. So when we have our Ohm's law wheel, we can put X sub L in for R for our formulas. Now this means that if we're trying to find the current, I total, that would equal V total divided by X sub L total, and X sub L total will equal V total times I total. So if we look here, we've got a couple of different formulas that we could use to find the total inductive reactance. We could find it based on the individual inductive reactance. We can find it based on the total inductance, or we could find it based on the total voltage and the total current. All right, now let's look at the next type of circuit that we'll see, which would be a parallel circuit. So let's say that we had a parallel circuit and we have inductors here. So here's my parallel circuit. All right, and we have some frequency, and this is L1, L2, and L3. So for this circuit, the total inductance, we're going to use the inverse of the sum of the reciprocals formula. So this is like resistors in parallel. So we'd have L1 to the negative 1, L2 to the negative 1, plus L3 to the negative 1, all to the negative 1 power. This would be the total inductance. For these circuits, just like the previous ones, this is always true, X sub L equals 2 pi FL. So for this one, we would also have an X sub L1, X sub L2, and X sub L3. And X sub L total is going to be the same formula. So we'd have X sub L1 to the negative 1 plus X sub L2 to the negative 1 plus X sub L3 to the negative 1, all to the negative 1. We could also get X sub L total by doing 2 pi F L total. So if we know the total inductance this way, we can find the total inductive reactance by just using this formula. We could also use the Ohm's law formulas just like we did in the previous, just like we talked about in the previous one, where we have V total equals I total times X sub L total. I total equals V total over X sub L total, and X sub L total equals V total over I total. So there we go. We're out of a little bit of space here, but all of these Ohm's law formulas are still good. All right. The next type of circuit that we'll have that we'll see is a combination circuit. So this is one that has series and parallel components. So when we get to this type of circuit, we'd have L1, L2, and L3. We would also have X sub L1, X sub L2, X sub L3. So each inductor will have an inductance and inductive reactance. For these problems, what we're going to do is find all inductive reactances, and then we're going to solve it like a combination resistor problem. And we'll look at some examples of this. So when we have a combination circuit like this, we're going to find the individual inductive reactance, and then we'll solve it like a resistor problem. All right, so let's look at some examples. So let's draw our first example. We'll do a series problem. So here we have a series circuit. So we're going to put 3 inductors together here. All right, so we'll have L1, L2, and L3. V total, for this one, let's say it's 20 volts AC. Now we need to be careful because if this is not an AC, the first step is always going to be to convert to AC if needed. So if this is the first thing that we got to look at and make sure that that's in volts AC. If it's in peak or peak to peak, then we have to make a change. The frequency for this one, let's say the frequency is 100 hertz. And let's make L1 15 millihenries. We'll make L2 20 millihenries. And we'll make L3 30 millihenries. All right, so for this problem, we have 3 resistors, or I'm sorry, 3 inductors, excuse me, and we have the voltage supply. So what I'm going to do to start with for these problems is I'm going to make a table. Now what we're going to do for this is we're going to solve it kind of like the ones that we've done before, but we're going to add a new column to our table. All right, so here is the start of our table. And let's first put in the knowns. So on our table, the way this is going to work is we have voltage, current, inductance, inductive reactance, and then power. Okay, so this would be L1, L2, L3, and total. So the total voltage is 20, so we can put that in there. The inductance, we'll put those in. We have 15 millihenries, 20 millihenries, and 30 millihenries. All right, so those are our knowns. Remember when we get to it that our Ohm's law formula, voltage equals current times the inductive reactance. So we got to make sure that we convert everything to inductive reactance. Now for this problem, this is a series circuit. So series circuits still follow the same, they still act the same way, which is the current is the same. So this would be I total. And that's going to be the same in the whole problem. All right, so let's do, let's start off with, do these in green maybe. All right, so the first thing that we're going to do is we're going to find X sub L1, XL2, and XL3. So X sub L1 is going to equal to 2 times pi times the frequency times L1. So that would be 2 pi times 100 times 15 milli. So X sub L1, so let's punch that into our calculators. Get my calculator out here. So let's see, do 2 times 3.14. Remember that for pi, we can write in 3.14 for pi, times 100 times 15 milli. And when I do that for this one, I get 9.42 ohms. So that's going to go over here, 9.42 ohms. All right, so now let's go to the next one, X sub L2. All right, so this is going to be 2 pi times F times L2. So this is going to be 2 times 3.14 times 100 times 20 milli. So X sub L2 is equal to 2 times 3.14 times 100 times 20 milli. And for this one on my calculator, I get 12.56 ohms. All right, so I'll put that over here, 12.5 ohms. Then let's do X sub L3, which is going to be 2 pi FL3. So this would be 2 times 3.14 times 100 times 30 milli. Two times 3.14 times 100 times 30 milli, and I get For XL3, I get 18.84 ohms. All right, so now I found 18.8 ohms for XFL total. Now the next thing I'm going to do, and let's pick a different color for that, let's try orange, is I'm going to find the total inductance and the total inductive reactance. So the total inductance is going to be L1 plus L2 plus L3. So here I got 15 milli plus 20 plus 30. So 15 milli plus 20 milli plus 30 milli. So for L total, I get, punch that in my calculator, 15 plus 20 plus 30, and I get 65 millihenries for this one. All right, and then the last one I'm going to do is X sub L total. So this should be henries. So I don't have the exact same color here. And then, all right, so let's do X sub L total. XL total equals XL1 plus XL2 plus XL3. So that would be 9.42 plus 12.5 plus 18.8. So X sub L total equals 9.42 on my calculator plus, 12.5 plus 18.8, and I get 40.7 for X sub L total. So we'll do that here, 40.7. All right. So now what I need to do is find the total current. So I'm going to do that on the next page here. All right, so the total current, I total, so what we're looking at is the total current here is going to equal V total divided by X sub L total. So we would have 20, so 20, this is our 20 divided by 40.7. So if we do that, 20 divided by 40.7, I get that my total current is equal to 491 milliamps. So let's put that in here. We'd have 491 milli. So the current is constant in this one, so they're all going to be 40.91 milli, or 491 milli, excuse me. All right. So now the next thing we can do is find the voltages. So let's do that. So we have the voltages. I guess we'll use red, that's fine. So we have V1 is going to equal I1 times X sub L1. So I1 is equal to the total current. So we'd have 491 milli times X sub L1 is 9.42. So if we do that on our calculator, we got 491 milli times 9.42, and I get 4.62 volts for this one, 4.62. All right, so let's do V2, which would be I2 times X sub L2. So we would have 491 milli times 12.5. And for that one, I get 6.14 volts. So 6.14 for that one. And then for V3, I get I3 times X sub L3. So I'd have 491 milli times 18.8. And if I do that one on my calculator times 18.8, I get 9.2 volts. Now, just to double check these, I'm going to add these up. So on my calculator, I'm going to add up these to see if they add up to the 20. So 4.62 plus 6.14 plus 9.2, I get 19.96. So that's pretty close to 20. So I just added up these three numbers to see if I made a mistake. All right, so let's transfer this one back over, 9.2 volts. All right, so now that we're at this point, we can calculate the power. And the formula for power equals voltage times current. All right, so for power, let's pick another color here. We'll do this one. And we'll do all of these down here. So we have, or actually maybe we'll do these here. So power 1 is going to equal V1 times I1. Because this is a series circuit, we're going to use this voltage. And this current, looks like I don't have enough. Let's do this over here. So we'll have power 1 equals V1 times I1. So I'll have 4.62 times 491 milli. The current everywhere in the circuit is going to be this. So I'm just multiplying it times each one of these. All right, so let's do that on my calculator. 4.62 times 491 milli, and I get 2.26. And this, for this class, we could use watts. It's probably more accurate to say that this is a var, but if you use watts for this class, that's fine. P2 is V2 times I2, so that's going to be 6.14 times 491 milli. So I'll punch that into my calculator, 6.14 times 491 milli, and I get 3.0 vars. P3 is V3 times I3, so that would be 9.2 times 491 milli. So 9.2 times 491 milli, and I get 4.51 bars. And then P total is going to be V total times I total. So that's 20 times 491 milli. So P total would be 20, would be 9.82 bars. So, all right, so let's transfer these back up. I have, for the first one, I have 2.26, and then we have 3, and then we have 4.51, and then we have 9.82. All right, so we've completed our series example. So if we go back through our steps, the first step, and this is always going to be the first step, is to make sure, step 1 here is to make sure that our power supply is in volts AC. Step 2 is going to be to find all the inductive reactances. Step 3 is going to be to find the totals, L total and X sub L total. Then we have step 4, which is find the total current. Step 5 is going to be to find the individual voltages, and then step 6 is going to be to solve for all of the powers. All right, so let's go next to a parallel example. So here is our parallel circuit. So we have some inductors, and I'll just do 3 inductors again, just like we did for the other example. Let's say for this example, so this is going to be L1, L2, L3, V total. Let's say this time that we have 15 volts peak, and our frequency is 750 hertz. For L1, let's say that we have 150 millihenries, 200 millihenries, check that, that's pretty much the same one that we did last time. Let's try this again. So let's make up some different ones. Let's say that we have 7 millihenries, 500 microhenries, and 800 microhenries. So we'll have a little bit different numbers here, and then based on that, maybe we should change this. Let's make this 2 kilohertz. So my apologies here. We're kind of trying to make this up as we go. All right, so I think we have it. So the first thing that we need to do is our power supply is in peak, so we got to convert that to RMS. So V total would equal, if you remember our formulas, it's 0.707 times V peak equals the AC. So we'd have 0.707 times 15. So V total would equal, let me punch that in my calculator real quick, 0.707 times 15, and I get 10.6. And that's volts AC. So this is the voltage that we're going to use in the problem as we solve for all of our other items. All right, so the first thing I'm going to do here is I'm going to make a table again, just like I did last time. And so we'll make this thing first. So I have voltage, current, inductance, inductive reactance, and power. And let's go through and we'll write in the things that we know. So this would be L1, L2, L3 total. And then we have 7 millihenries for this inductance, 500 microhenries for L2, and 800 microhenries for L3. Okay. The next thing that we need to do is find the inductive reactance. So we're going to have X sub L1, X sub L2, and X sub L3. So let's do that first. So we have X sub L1, that's going to equal 2 pi F L1. So we have 2 pi, the frequency here is 2K. So we put that in there, and then times 700 millihenries. And so X sub L2 is equal to, so let me punch that into my calculator, 2 times 3.14 times 2K times 7 millihenries. And if I punch that into my calculator, I'm going to round this up to 88 ohms. So that would be here. I'd have 88 ohms for X sub L2. I'm sorry, x sub L1. Excuse me, that should be x sub L1. I put it in x sub L1. All right, so next one, the inductive reactance for inductor 2 would be 2 pi FL2. So that's going to be 2 pi times 2k times 500 micro. Now I got to be careful. This micro is to the negative 6, 10 to the negative 6. So we got to be careful with that one. So let's punch that into our calculators. We have 2 times 3.14 times 2k times 500 micro. And when I did that, I got 6.28. I'm going to punch that in one more time to make sure that I did it correctly. Yep, looks like I did. So we have 6.28 for this inductance. And then the last one, x sub L3 is 2 pi FL3. So that's 2 pi times 2k times 800. Again, we have micro. So x sub L3, 2 times 3.14 times 2k times 800 micro. Again, micro to the negative 6. I get 10, approximately 10 ohms. Looks like I forgot the ohms here. So that one's ohms. So now I have 10 ohms. All right. So we found the individual inductive reactance. Next, what we're going to do is find the total inductance. So L total. Now this is a parallel problem, so we got to use the parallel formula. It's going to be L1 to the negative 1 plus L2 to the negative 1 plus L3 to the negative 1. So here we would have, and this one we got to be real careful with. So I'm going to, on my calculator, I'm going to put parenthesis 7 and hit the EE button, negative 3, and then I'm going to hit the negative 1 button, plus 500 EE button, negative 6, and then to the negative 1 power. So this button is either x to the negative 1 on your calculator or 1 over x, depending on what calculator you have, plus 800 e negative 6 to the negative 1. I close the parentheses and then hit the negative 1. So when I do that, so let me do that on my calculator real quick here. So 7 milli to the negative 1 plus 500 micro, that's the negative 6, inverted, plus 800 negative 6 inverted equals to the negative 1, and I get, so when I did this, and I did it wrong because I got 1.2 millihenries, and that can't be right. So I'm going to do this on my calculator again. So let's try that again. So it's 7 milli to the negative 1 plus 500 micro to the negative 1 plus 800 micro to the negative 1, close parenthesis to the negative 1. All right, so I had to do that a couple times on my calculator. I got a different calculator that I'm used to using, and I get 296 microhenries. Now the reason why I knew that this was the wrong answer is it has to be less than the smallest inductor. So it needs to be less than the 500 microhenries. So on my calculator, the way that I had to type it in was I had to do each of the terms 7e to the negative 3 in a parenthesis and then negative 1, and then add to each one. And then I hit equal, and then I inverted it. So get a new calculator. Should be 296 microhenries. All right, so let's do x sub L total next. So this is going to be, the formula is x sub L1 to the negative 1 plus x sub L2 to the negative 1 plus x sub L3 to the negative 1 all to the negative 1. So here I would have 88 to the negative 1 plus 6.28 to the negative 1 plus 10 to the negative 1. And if I do that on my calculator, so let me give that a try. So I have 88 to the negative 1 plus 6.28 to the negative 1 plus 10 to the negative 1, close parenthesis, to the negative 1, and I get 3.96. Sorry. It's 3.695, so I'm going to round that up to 3.7. So this would be 3.7 here. All right, so now, and maybe I should have did this at the beginning, just thinking of it now. Because this is a parallel circuit, the voltages are all the same here. So that means the known voltage is 10.6. So that means that I can write in the voltage for each of these as 10.6 and 10.6. And for the parallel circuits, just like before, if we remember, the total current equals I1 plus I2 plus I3. So these are gonna add up to this, and so now I can find each of the individual currents. So we'll do that on the next page here. So here we'll start it off. We have I1 equals V total over X sub L1. So we got to go back, get to the right page here. So we have, still not there, 10.6 is the total, and 88 is X sub L1. So we'd have 10.6 divided by 88. So let's do that one. 10.6 divided by 88 is 120 milliamps. So that would go here. All right. And remember, we're using 10.6 because we had to convert it, the 15 volts peak to AC. All right, so let's go to the next one, I2. And that's going to be equal to V total divided by X sub L2. So that's 10.6 divided by 6.28. So 10.6 divided by 6.28, and I get 1.69 amps for that one. So we'll write that in, 1.69 for that one. And then the next one, we have I3 is V total divided by X sub L3. So we'd have 10.6 divided by 10. And that's going to be 1.06 amps. So we'll put that in here, 1.06. Next we can find I total. I total is going to equal I1 plus I2 plus I3. It equals the sum of these, so we just have to add them up. So we'd have 1.06 plus 1.69 I add these up, I get 2.87 amps. All right, so 2.87 here. All right, so now I have the total power. Now, as a double check, maybe I'll do that over here. I total should equal V total divided by X sub L total to see if I did this correctly. This should be a total. So if I take 10.6 and I divide it by 3.7, I should get the same thing, 10.6 divided by 3.7, and I get 2.86. And that matches 2.86 and 2.87. So there's two ways to get I total. I can add the individual currents, or I can take the total voltage divided by the total inductive reactance. All right, the last thing that we have to do is the power, so we'll do that one next here. So P1 equals V1 times I1, so this is going to be 10.6 times 120 milli, 10.6 times 120 milli, so that's going to equal 1.27. P2 is V2 times I2, so that's 10.6 times 1.69. Let's make these times. 10.6 times 1.69, and I get 17.9 for that one. P3 is V3 times I3, so 10.6 times 1.06. And that's 11.2. And then P total is going to equal V total times I total. So that's going to be 10.6 times 2.87. And 10.6 times 2.87. And I get 30.4 for that. All right, so let's transfer those back up. The first one was 1.27. Second one is 17.9. This one was 11.2. And then the last one is 30.4. All right, so we have completed our parallel problem. All right, so let's look at next at a combination circuit. So a combination circuit would look like this, where we have a series part and then we have a parallel part. So this would be L1, L2, and L3. So let's say that the voltage here is 30 volts AC, and the frequency is equal to, let's say, 300 hertz. Let's say L1 is 200 millihenries, L2 is 400 millihenries, and L3 is 600 millihenries. All right, so here's our problem. So the first thing we're going to do, just like always, is we're going to make a table for our answers. So we'll put those on here. So we have voltage, current, inductance, and inductive reactance. For this one, we're not going to do the power. And then we have L1, L2, L3, and total. All right. And let's start off with putting in what we know. So let's do that first. So the total voltage is 30. It's already in volts AC, so that's good. And then we'll put in our inductors. So we have 200 milli, 400 milli, and 600 milli. Now before we get into all of the math part, anytime we have a series parallel circuit, what we should do is we'll start off by circling the things that are in series. So these two here are in series. So that means that the total current here is going to be the same as the current through inductor 1. And these two are in parallel, which means that their voltage is going to be the same. So here's their voltage. Those are the same. And what we're going to do before we get too far is we're going to simplify the circuit, and we're going to put in a new inductor that I'm going to call LA for the parallel combination of those two inductors. And then I'm going to redraw the circuit with the first inductor, L1, and then LA. And this would still be a 30 volt AC supply. And then we're going to have an additional table here for the second circuit. So let's put that in here. And then this one will be voltage, current, inductance, and inductive reactance. This is going to be L1, this will be LA, and this will be total. Now the current in this circuit is going to be the same as the total current in this circuit. So let me put this on here. So the current in this circuit, I total, is identical to the current here, which will be I total. So that's going to be this current. So we'll circle all of that. That's a series circuit. So the currents are all the same. And then the voltage here is the voltage that we're going to transfer back up. And then we can put in here the stuff that we know, that this is 30, this is 200 milli. Okay, so we've started off the problem and we made our two tables. And so now what we need to do is find the inductive reactance. So let's start with that. So we need to go through and find the individual inductive reactances. So we have X sub L1, X sub L2, and X sub L3. We're going to find those first. So we have 2 pi times the frequency times L1. So this is going to be 2 times pi. The frequency of this circuit was 300 hertz. So we have 300 for the frequency times 200 millihenries was the inductance of the first one. So we had a 200, 400, and a 600. All right, so let's do the first one, 2 pi times 300 times 200 milli. 2 times 3.14 times 300 times 200 milli, and I get 377 ohms. All right. Next one, we'd have 2 pi FL2. So this would be 2 times pi times 300 times 400 millihenries. This is the inductance L2. And so if I do that, 2 times 3.14 times 300 times 400 milli, I get that I have 780 ohms. And then let's do x sub L3, 2 times pi times F times L3. So I have 2 pi times 300 times 600 millihenries. And if I do that, I get 1.13 k ohms. All right, so let's transfer those back up. So this was 1.13 k. And then we had 754. And then we had 377. All right, so if we go over to this circuit here, I'm going to write those in. So this was 377. So let's put that in, 377. Now we need to find next X sub L A, which would be the inductive reactance of X sub L A. So if I go back and maybe I'll try to sketch these in here. So this is 377, this is 754, and this is 1.13 K. So I can find the inductive reactance of these two in parallel by taking 754 to the negative 1 plus 1.13 K to the negative 1. And if I do that, 754 to the negative 1 plus 1.13 K to the negative 1. And if I do that, I get 452 ohms for this resistor. So this would be 452. Now, I'm not going to worry, well, let's just do it. So if we wanted to find L total, we would take 400 milli to the negative 1 plus 600 milli to the negative 1. And we could find that the total inductance for that one is 240 millihenries. So I mean, we could do this. We don't need it for this problem. All right. So now what we can look at is, let's solve this one for the, let's solve this problem. So here we have two inductors in series, so we can add these up. This would be 440 milli. Again, we don't need the inductance anymore. X sub L total is going to equal the X sub L1 plus X sub L2, so this is 377 plus 452. Maybe I'll write the formula here. X sub L1 plus, sorry, not X sub L2, it's X sub LA. So I'm adding these two up. This one was 452, so I'm just adding these two together. That's like right here, I'm adding these two. So X sub L total is going to be equal to 377 plus 452. I get 829 ohms. All right, the next thing that I can do is find the I total. So I total is V total over X sub L total. So that's going to be 30 divided by 829. And I'm going to change the color here because I think that that one might be hard for you guys to read. So let me write this again. Not sure on the video if this is easier to read. I total is V total divided by I total. So I'd have 30 divided by 829. And if I do that, I get 36 0.1, I'm just going to leave it as 36 milliamps. So I have 36 milliamps, 36 milliamps, 36 milliamps. All right. So next thing I can solve for is V1 and VA. So V1 is going to equal I total times X sub L1. So this is 36 milli times 377. And for that one, I get 13.6. So I have 13.6 here. For VA, that's I total times X sub LA, which is 36 milli times 452. And that equals 16.3. Now if I add these up, I get, looks like 29.9, which is pretty close to 30, so I think I'm on the right track. All right, so now I can transfer this up. This one would be 13.6. This would be 29.9. This would be 29.9. I can bring up the currents. So this would be 36 milli and 36 milli. I can also bring up the total inductance, 440 millihenries, and then I can bring up this one, 829, and all I have left, and I'm going to make this really messy here, is to find the currents for L2 and L3. So I would have I2 equals V2 over X sub L2. So that would be, oh wait just a second, I screwed this up. So this is not 29.9, excuse me, and this is not 29.9. Whoops. This is 16.3. I'm sure at home you guys all found that. Just testing you. All right, 16.3. These 13.6 plus 16.3 need to add up to 30. All right, so then I would have 16.3 divided by 754, and then that would be the current that's going to go here. So let's do that. 16.3 divided by 754, and I get 21.6 milli. All right, and then I3, and I'm really out of space here. I3 is going to be 16.3 divided by 1.13 K. So I3, 16.3 divided by 1.13 K is 14.4 milli. So I get 14.4 milli here. And then if I add these two together, do I get 36? And it looks like I do. So I think that these are correct. Apologize for the messiness. All right. So that is the last problem out of the homework examples for inductors. Thank you.